Let's be honest, gifts are hard. In my eyes, if a person really wanted something, they'd buy it themselves. So I tend to make my own gifts. But this is a problem when the person you're making for literally has a CNC machine, backed by a degree in not engineering. Like, what the hell do you make for someone who can make anything? And then it hit me. I can make an experience.
It didn't do that before, did it?
You've unlocked something on the inside.
Oh my god.
And in the case of this gentleman, I think I can make an experience he will hate.
It's a maze that you can't see.
Welcome back to Inheritance Machining. So why am I making a gift for a fuzzy man in Upside Down Land? Great question. I'm glad you asked. Turns out another fuzzy friend of mine named Eric, with a K, really likes making gifts. So he wrangled up a bunch of other YouTube machiners to make gifts with him, but for each other. It's basically a Secret Santa. Except we're calling it Toolroom Takeover, and we're doing it in August. From this list of awesome metalworkers, I picked your boy Rowan from the channel Not an Engineer. An Aussie known for his CNC mill that he built from scratch. A hard act to follow for sure. So I'm going to give him a real challenge and make him a puzzle. I've had pretty good success making these in the past and even gotten some good feedback.
That's sneaky. Oh my god! Well, now the what?
So I think I've got a good feel of where to draw the line. Let's get into it. I like to start puzzle designs with a general shape. From here, I really just start throwing stuff in I think will be hard to figure out. Like this maze. It's long, has lots of dead ends, you won't be able to see it, and the real end isn't the end at all. There are a lot of interlocking pins, slides, detents, and other engineering-sounding words that I can't really explain without animating this whole model, and I don't really feel like doing that, so let's just take a gamble and start. Now because we're all machiners, and even worse, YouTube machiners, we're all aware of our proclivity to overdo it. So there's a budget. Each creator has to keep their project under 150 smackaroos. Something I kind of sort of forgot when I placed my McMaster order. So I'm using some leftover stress proof from another project. This is one of the end caps and one side of this just needs to look the part. By that I mean unassuming, because the other side is where all the business is. Business that will be hidden of course, and business that I'll make on the mill. I need everything to be centered, so I'll use the coaxial indicator to find that center, and I can start adding some of that business. Stop saying business. This end cap is actually the last piece of the puzzle. Once it's open, I'll have a nice little surprise inside for Rowan. But I don't want it to open like you'd expect. The cap is round, so you'd probably think twist, right? This doesn't look very spinny though, does it? That's because it's going to be more of a slide hatch than a cap. It's not just unintuitive, but dare I say, anti-intuitive. And I love throwing little curveballs like this into my puzzles. We'll round this out with a tapped hole, which implies hardware of some sort, and I generally don't like using hardware in my puzzles because I have a weird hang-up about things being completely disassemblable without tools. But I really didn't want to have to make this itty-bitty ball detent on top of everything else. That's actually one of the unexpected perks of what some people might call a controversial piece of tooling in my shop. The X1 Carbon 3D printer from bambulab, the sponsor of this video. With the pile of ideas, projects, and side projects I feel compelled to start, there's just no way I could machine everything by hand. Nor would I want to. Machining a never-ending stream of gridfinity bins just wouldn't be that fun. And while it might be a good challenge, things like this grease adapter, well, I'd rather use my micrometers as welding clamps. So my bambulab printer fills in the gaps in my attention span and my patience. It's a fully refined and ready-to-use tool. You don't need to fiddle with bed leveling. You don't need to chant to the firmware gods. You just toss in your model, feed it filament, hit print, and by the time you're done noodling over your next project, it's already finished with the first. That speed alone has cured at least 40% of my project commitment issues. I can't tell you how long I've needed a dial indicator holder for my lathe, but never bit the bullet. So now when I need something quick without the commitment, the printer is my tool of choice. Especially for things like this call it simulator from a previous video. I needed it for like 10 seconds of demonstration and it would have otherwise taken me all day to make by myself. It's like having a shop apprentice who never complains, never steals your good calipers, and never asks what's in the grumpy wooden box. I should point out that you don't actually need to know how to 3D model either. With the MakerWorld browser built right into Bamboo Studio, there are literally hundreds of thousands of user-generated models ready to print, and it's not all silly knickknacks, not that there's anything wrong with that. But there are equally as many useful tools, gadgets, and accessories people have already spent the time coming up with. So the days of having to become a 3D printer enthusiast just to get a few basic prints are over. The X1 Carbon handles engineering-grade materials, multicolor prints with the AMS, and filament doesn't cost more than your mortgage, unless you have a problem. I won't judge. So if you're like me and prefer spending less time babysitting temperamental robots and more time getting overly friendly with your lathe's knobs, then yeah, get a bambulab printer. It's a shop upgrade you didn't know you were allowed to have. Use the link in my description. It helps the channel, feeds the box of shame, and tells bambulab that sending a fancy printer to a guy who thinks CNC is a suggestion was a good idea. Alright, we're going to look at it, very nice, and moving on. Let's make the other cap. This looks a lot like the first, mostly because it's exactly like the first, except where it's not. So let's skip to my loot of that part. I'm adding another touch of anti-intuitiveness with a dovetail. Another slide where you think twist. And to make sure things don't bind up, some micro chamfers. I might not be able to see them, but I'll know they're there. Lastly, this gets some holes. One blind and reamed for a pin, and one through and elongated for reasons. Just go ahead and get used to stuff not making sense right now. And that rounds out this one, giving us the two ends of this puzzle sandwich. Let's make the pastrami that goes in between. I'm going to continue to try to keep this under budget. So rather than use this bar that's the right size and I paid money for, I'm going to use this one that's too big and I paid money for 3 months ago, which means free. The start of this is pretty straightforward, so let's just enjoy making some chips together. After the most boring part of this process, I'll add a nice little groove on the inside here, again for reasons. The final pass on the outside guarantees it's concentric with the inside, you know, just in case that hefty drilling operation cattywampafied anything. Then I can part this off, clean up the other end, and I'm sure you can guess where this is going next. I'll start with this very, very deep hole first. It's basically snugged up right against the inner bore, and if this drill drifts for some reason, well, I don't want that mistake to be the last thing I do. Looks good. I'll ream it so we can get a nice smooth bore, then we can welcome back our itty-bitty friend here. The idea is to make a sort of funky cutout to match up with a funky protrusion on the cap from earlier. It's more elaborate than that though, because the cap actually has to be able to move as well. So we'll bring back the keyway mill to scoop out metal underneath so we can do just that. Oof, nice. Alright, now we have a problem because I need to add a feature to the other side, but it also needs to be squared up with everything I just did. Fortunately, I've got this adjustable parallel I can wiggle in here, which gives me a tramming reference for the dial indicator once it's all stood upright. It's a little jank, but gets the job done. Once tightened down and center located, I can use the boring head to add a sort of scallop area thing. Now I can already hear you saying, Brandon, that wasn't all that janky. Well, hold my indicator, because now I've got to turn this on its side and add a feature at an angle, which probably has a very simple and intuitive means of aligning, but I couldn't see past my own brilliant adjustable parallel idea. So after dropping the angle gauges, scooping grease on them to hold them in place, dropping them again, and eventually wising up and using a clamp, I was able to tram it to 30 degrees and pop my holes in here completely out of focus. Lastly, after all that effort to precisely align everything, I'll eyeball this last cut for yet another reason, then that's it. Our puzzle sandwich is complete, or at least the major visible parts of it. But remember, this is all just a facade. We have a whole lot more in store for Rowan inside. So let's get to the really confounding bits. I did actually have to spend money on this brass, unfortunately. While not strictly necessary, it will make the puzzle's movements a lot smoother. With the rough diameter cut to size, we're ready for the more puzzling stuff. And rather than remove part from chuck, whole chuck come with. Because, whoop. There we go. Because there's literally no way I could finish this without the rotary table. In particular, the maze. But while this thing is still laying down on the job, I'll cut another dovetail. This time of the female variety. Why, you ask? Well, because it's brass, of course. But also so that it matches the cap we made. After a couple more nonsensical slots and holes, this whole part went sideways. Literally. The rest of this has to be done from a more alert position. But I also need the rest of this to be aligned with the features I just machined in the end. Something that would only be possible if my flatulent foot flailing fixture flipping included tramming the table when it was laying down. Which it fortunately did. So after getting centered up in this new position, a ball nose end mill scoops out a nice little intersecting divot with the hole we just drilled, giving side access to this hole while making it fondle friendly. I'll drill and ream a hole down in here, then rotate and drill and ream yet another. And finally, we can get to the aMAZEing part. I may be the one making the maze, but that doesn't mean I don't have to start at the beginning like everyone else. I will confess, though, I do have a roadmap. A roadmap I will kindly not be sending to Rowan. Okay, hopefully I did all that right, because I really won't know until it's all together. Let's get this back over to the lathe for some cleanup. You probably couldn't feel it, but this thing is riddled with burrs. So a little emery cloth treatment takes care of that. There we go. Now I can lop this off and we can finish out the other end, facing it to length, then adding a very boring little compartment. Perfectly suited for a not so boring, but definitely little surprise for Rowan. Finally, back to the mill for some threaded holes for more ball detents. And amazingly, the V-blocks had a slight gap that let me square up the part with a simple dowel pin. I don't know why I felt necessary to point that out, it just really floated my boat. Alright, just like that, all the big fancy parts are done. But they aren't going to do much without all the special pins that go in between. So get ready for a whole lot of high-speed turning. First up is a fairly simple pin with a wide groove in one end. There's not much I can say about this other than, yeah, it's got a groove. But after parting and figuring out where the hell this went, I'll use the round tip of another insert to make a curved groove in the other end that should give a nice spot for a ball detent to cuddle up in. Pins 2 and 3 are even simpler, but still need accuracy. So when cutting the final diameters, I just kept taking spring passes until the chips stopped coming, i.e. the material stopped deflecting away from the cutter. Then it's another detent groove before parting off and finishing the other end, one of which gets turned down even smaller. Now pin 4 is a little special. It gets a reduced section before parting off and cleaning up the other end, but that's not the special part. For that, we need the collet indexer. So I can spin this in the mill and cut a nice little, well, I don't really know what you would call it. But it left a pretty gnarly burr on here, so I'll clean that up on the lathe and boom. Now I'll give you a little sneak peek here because I discovered a problem with my design. This pin goes in the hole in the brass core, and the whole idea is that you should be able to spin this via the fondle-friendly hole in the side, but that doesn't work. It needs more traction. So back in the lathe, I'll turn down a short section before bringing in the knurling tool. This diameter reduction is necessary because knurling actually increases the diameter slightly, which I'm sure you can imagine would wreak absolute havoc on the inner sanctity of my beautiful brass masterpiece. There we go. Pin number 5 isn't a pin at all, it's a bushing. So after turning down the diameter, I'll drill and ream a hole, which I discovered was a bit loose for my preference, so I started over and promptly used the same reamer again. Third time's the charm. Leaving just pins 6 and 7, which, well, you get the idea. Okay, I think that's everything. Let's get our assembly on. One suspiciously simple puzzle ready to go. No tools, no force, no phone a friend. Just an hour or two of head scratching. Hopefully. Let's get this off to Australia. I'm just kidding. I debated whether to show the solution or not, but there's a non-zero chance Rowan won't be able to solve it. In fact, that would make me overwhelmingly happy. But it would also leave you, the viewer, completely underwhelmed. So, this is the state the puzzle would be in if I had a 9,000 mile long arm and could hand this to Rowan. The caps kind of wiggle a little bit, but don't turn. This doesn't seem to do anything. There's a mysterious hole directly opposite of that. And then, of course, there's this here. It seems to be backed by a spring, and that's because it is. Push on this, it slides. And when it slides, it pushes that pin out. Rowan doesn't know it, but that's the start of a maze. So let's navigate to the end. Avoiding all the false ends, we can work to the next step. Okay, that's the end. But it's not really the end because the end isn't the end. What Rowan has to figure out is that he also needs to be pushing on this pin while he's navigating the puzzle. And he'll find that there's a point where that pin goes in. Now it's locked up. So what now? Well, if you remember, we put some knurling on this finger fondling friendly pin here. Well, that's so that we can twist it. And that pops out, giving us a nice little tool we can use to solve the rest of the puzzle. I'll go ahead and take this cap off. So now I can push our pin in, which pushes into another pin, and that makes this spin all the way around. We're no longer in the maze. If you remember, there's a long hole through here, and we made a long pin to fit in there. And what we have to do is find that one spot where it lines up, and we can pull on that. And when we do that, this cap comes loose. And boom, that's the end of the puzzle. So once again, that's pin, slide, that starts the maze. Reach the end of the maze, hold this pin in, find the point where it stops, pop the tool out, set the cap down so we don't drop it, push the pin through, spin, find the point where it engages with our inner pin, remove the cap. And I can add a nice little surprise in there for Rowan. And a nice little surprise is what he'll get, but I'll save that for his video. I think also knowing the solution while watching Rowan struggle to figure out will be highly amusing. I'll write a brief love note explaining what it is so that Rowan doesn't think it's a paperweight, and so Australian Customs doesn't think it's a pipe bomb. Let's send it on its way. Now you may have forgotten, but this video isn't over. I have my very own package to open. This is a big circular gift-giving YouTube machiner collaboration after all. This is from Nick at Jonesy Makes. This looks far larger than any of the projects I'm familiar with him doing, so I am very curious. box within a box. Very nice box. Okay. Tools. I need tools. What did you make, Nick? Huh. This way. There's a lot of stuff in here. 10, 9. This is the big one. Dear Brandon, please find enclosed your gift for Toolroom Takeover 2025. If you've unwrapped any of the packages yet, there should be 10. I imagine you've worked out that I haven't actually made this. Instead, I chose to restore this intriguing old machine for you. I love it and I hope you will too. Oh my. Oh, the ratchet. In case you're wondering, it's a linear dividing engine for engraving linear scales on tools, scientific instruments, and the like. I couldn't find out where or when it was made or by whom, but my best guess is that it was probably made in London circa 1850. Oh boy. It's a lovely looking thing and a joy to use. Hopefully you get some enjoyment out of it. Apologies for having to send it in bits. It was the safest way to ship it. It goes together pretty easily, and I include a photo of the assembled machine for reference. All the best, Nick. Dude, holy That is the one thing I've not done. Well, there's a lot of things I haven't done on projects. I have not put scales on any of my projects. Oh my God. Oh. They made this in 1850. Wow. Wow, wow, wow. Oh man, I hope that's not super important. Oh, well, there's no instructions, so I just have to go by this picture. Do you heat seal this bag? Dude, I'm gonna guess those go there. You probably go down in there. What's funny about this is if I got a full set of instructions, I would still just look at the picture. How did you even find something like this? I feel like this should be in a freaking museum. This beefy boy needs to go slide on there. I'm gonna say that taking the gib off was the smart choice here. Dude, I have no clue if I put those legs on backwards. Lord, this is sexy. Just go under here. Yes. Oh, that is freaking stunning. I'm seeing how critical this piece is here. It needs to hold that, which is like a follower. It looks like it's supposed to ride in that groove. I don't want to do anything rash and just like JP weld this on. I feel like I need to give it some more thought. I see some pieces that I don't quite understand. Maybe I should spend a few minutes figuring this out before I try to commentate this thing. Okay. Okay, Nick, this is 100% up my alley. It's manual, it's old, it's brass, and I'm in love. I had no idea what to expect, but you absolutely nailed it. Thank you so much. I'm going to be making up an excuse to use this as soon as possible, and repairing this should make for a decent side project, once I figure out how that is. Commenters, please help. Now if you're watching this, you have two directions to go. You can go check out Nick's channel, aka Jonesy Makes, to see how he acquired this piece of art and how he restored it. Alternatively, you can go to Rowan's channel, aka Not an Engineer, to see not only what he thinks of this puzzle, but to hopefully see the surprise I left him inside. Rumor has it though, it remains unsolved. As always, thanks for watching, and see you next time.